I have a dream that one day this nation will rise up and live out the true meaning of its creed. We hold these truths to be self-evident, that all men are created equal.
Hello dear students. Today we are going to start with a new chapter, and the name of the chapter is Heron's formula. The learning objectives for the day are: first, we will recapitulate about the various types of triangles, and then we will apply an alternate method, that is Heron's formula, to find area of the triangle. We will not be using half into base into height, which we usually do. To start with, let's have a look at different types of triangles. First, on the basis of sides. If all three sides of a triangle are equal, then that type of triangle are known as equilateral triangle. If two of the sides of a triangle are equal and the third side is unequal, then that type of triangle are known as isosceles triangle. If none of the sides of the triangle are equal, then that type of triangle are known as scalene triangle. Next, on the basis of angles. If all three angles measures less than 90 degree, then that type of triangles are known as acute angled triangle, where all three angles are less than 90 degree. Next, if one of the angle is right angle, that is 90 degree, then that type of triangle is known as right angle triangle. This is a very common type of triangle. When one of the angle is obtuse, that is more than 90 degree, then that type of triangle is known as obtuse angle triangle. Now, in acute angle triangle, if all three angles are equal, that is each angle measures 60 degree, then such type of triangles are known as equiangular triangle. Now, in order to find area of a triangle, by common convention, we need two components, that is base and height. For a right angle triangle, having base and height is not a problem, as base and height are already defined in a right angle triangle. And in any other type of triangle, to find area using half into base into height, we need to first measure the height. That means we need to have the two components as base and height, since area of triangle is equals to half into base into height. So does that mean if we don't have base and height, we cannot find the area of triangle? Can't we find area of triangle in which height is not known to us and all we know are the length of the three sides? Do we need a hero to find area of such triangles? In fact, a hero with n, that is Heron, has already given us formula to find area of such triangles. Heron of Alexandria was an ancient Greek mathematician and engineer who was active in his native city of Alexandria, Roman Egypt. He lived between the 1st century BC and the 1st century AD and is considered the greatest experimenter of antiquity, and his work is representative of the Hellenistic scientific tradition. Hellenistic means native Greek. He has also published a well-recognized design of ancient Greek steam engine, Equilateral. This is a representative figure of Equilateral, which is an ancient Greek steam engine. So his works are really diverse. Now on to Heron's formula. Heron's formula states that area of triangle is equals to under root s minus a into s minus b into s minus c, where s equals to semi-perimeter, that is half of perimeter. So since perimeter of triangle is sum of all three sides. So S equals to perimeter by 2, or S equals to A plus B plus C, sum of all three sides, divided by 2. The derivation of the formula will be done later and the link will be attached in the description. For now, let's apply the formula to find area of triangle. So here we have a question. There is a slide in a park and one of its side walls has been painted in some color with a message, "Keep the park green and clean." If the sides of the triangular wall are 15 meter, 11 meter and 6 meter, we need to find the area that is painted in color. As you can see, the wall is triangular in shape, so we need to find the area of triangle in order to find the area that has been painted in color. So given to us are the sides of the wall. The first side measures 15 meter, so A equals to 15 meter. The length of the second side is 11 meter, so let's say B equals to 11 meter. And the third side is 6 meter, so C is equals to 6 meter. The order could have been different as well. Now, with the help of these sides, let's find semi-perimeter. So S equals to A plus B plus C by 2. That means S equals to 15 plus 11 plus 6 divided by 2. On adding the three sides, we will get 15 plus 11 is 26. 26 plus 6 will be 32. So 32 divided by 2. 2 ones are 2. 2 16s is 32. So S, or semi-perimeter of the triangle, is 16 meter. Now let's find the area that has been painted in color, which is triangular in shape, so area of triangle equals to under root S into S minus A into S minus B into S minus C. Now let's put the values. Under root S is 16 into S minus A, 16 minus 15 into S minus B, 16 minus 11 into S minus C, 16 minus 6. Now under root 16 into 16 minus 15 will be 1. So into 1 into 16 minus 11 will be 5. So 5. And finally 16 minus 6 will be 10. So into 10. So we have got 16 into 1 into 5 into 10 inside square root. Now 16 can be factorized as 4 4s are 16. 1 5s is 5. So let's write 5. And 10 can be factorized as 5 into 2. Inside the square root, we have a pair of 4 and 5 is also in pairs. That means 4 and 5 can be taken out of the square root. Meanwhile, 2 does not have a pair, so 2 will remain inside square root only. So 4 into 5 under root 2. 4 5s is 20 under root 2 meter square. So area that has to be painted in color is 20 under root 2 meter square. If you want to have exact answer, then you can put the value of root 2 as well as 1.41. Since it has not been asked in the question, we will keep our answer like this only. Now try this question, which is similar to the one which we have done in the video. Thank you and have a nice day.